Hi, for this chapter we'll be doing fractional equations. This is chapter 2.5. This is what we will learn. We will learn how to solve equations that have fractions in them, as well as check whether your solution causes a divide by zero error. What is that? We will learn this later. Okay, let's just do a quick recap. If you have an equation like this, we realize on both sides of the equation we have fractions. On the left hand side we have x divided by 2, on the right hand side we have 1/3, and it shows that they are exactly equals. So one of the ways that we can approach this question is that we can change both the denominators to the same denominator. So it looks something like this. You're quite familiar with this. Basically we're using similar equations and we convert both fractions on each side to the common denominator, which is 6. You should be familiar with this. So what it means is to say 3x divided by 6 is equivalent to 2 divided by 6. So because the denominator is exactly the same, we can also say that the numerator must be the same, which means in this case here 3x must be equal to 2. And of course all we need to do is just need to divide both sides by 3, and we will get the answer to find 1x, which is x equals to 2 over 3. So let's look at some examples for this chapter. So it's the same thing in this question. It's slightly more complicated. We have on the left hand side and a fraction. On the right hand side we also have another fraction. And we have a lot of numbers. Okay, 2x plus 1 is a number. 3x plus 4 is a number. And that is the denominator. 2x plus 1 is the numerator. So on and so forth. So same thing we can do is to convert both sides of the equation to a common denominator. We can do something like this, and it's exactly the same as what we've done before in the previous recap. Okay, even though it looks very complicated, we multiply the numerator and the denominator by the same number. Okay, you realize that this is actually equals to 1, and this is also equals to 1. So we're actually not changing the equation. All we're doing is just multiplying both sides by 1, but what this achieves is that it brings us to a common denominator on both sides, and the denominator is 3x plus 4 times 3x minus 2. Okay, you realize at this point I have not expanded anything and I do not need to expand anything. Okay, so this is what we had the previous slide. What we need to do now, of course, is we realize that because the denominators on both sides of the equation are the same, what this means is that the numerators must also be the same, which means this. Okay, now that we have this, we have basically gotten rid of the denominator. We can now expand, and we should get something like this when we do our simple expansion. And of course we need to simplify, and it reaches a common form that we're familiar with, and that is the quadratic equation. 3x squared minus 5x minus 2 equals to 0. So equals to 0 is what we want to achieve, and we have it in the form of ax squared plus bx plus c. So in that case we will solve as per normal. I won't go through this part. So what we can do is that we need to check the answer. So in order for us to check the answer, it means that the denominator of fractions cannot be 0. That means in the first case 3x plus 4 cannot be equals to 0, which means that x cannot be equals to negative 4 over 3. If not, it will get a divide by 0 error, which means that if you press your calculator you will get a math error. Okay, for example 1 divided by 0, you get a math error. Okay, same for, because there are two fractions involved in this equation, the original equation. Okay, two fractions, so I must consider the other fraction as well, which is x divided by 3x minus 2. This is the second fraction we must also consider. Same thing, the denominator cannot be equals to 0, and therefore x cannot be equals to 2 over 3. So as long as your answer, okay, is neither of these two, negative 4 over 3 or 2 over 3, your answer should be accepted. Let's take a look at another example. Okay, in this example I have on the left hand side two fractions that are actually need to be added up together that will give you the answer 2. So what we learned last year, okay, is where when we work with algebraic expressions, we can do the same as well. We need to have a common denominator, and we do this across all three terms. Okay, just to recall the three terms. This is one term, this is two terms, and this is three terms. So all three terms need to have the common denominator. Okay, so it looks something like this. It may look complicated, but you realize that the denominator is all the same, which is x minus 2 times x minus 4. And all the rest is simply the same as what we did before. We multiply the numerator and the denominator by the same number until we get a common denominator for each of these cases. Next, what we need to do is we need to simplify or combine the two fractions on the left into one. Okay, before we actually reach a common. Basically, once it says common denominator, it means that the numerators must be the same. Okay, I repeat again. Since the denominators are the same, it also means that the numerators must be the same. So therefore, I get this expression. And all I need to do is I need to expand it. And then after that, I need to simplify. And it gets back to the form that we're very familiar with. Ax squared plus bx plus c equals to 0. And we just need to solve this. Same thing, we also need to check whether it causes any of the fractions here to be equals to 0. So simply x minus 2 cannot be equals to 0. So x cannot be equals to 2. And x minus 4 cannot be equals to 0. So x cannot be equals to 4. So realize that our answers, okay, x equals to 3, x equals to 6 are not the same as these two answers. So it means that we can accept both the answers. Okay, so for practice, please try it 16 and try it 17.